Hi, I am Dhananjay Zavde. I am from the Adams product development team. Let me take you through a recent enhancement in the Adams product suite, which is for the simulating multi-body dynamic model in the real time. These features has been named as a Adams real time. In the Adams, you typically deal with moderate to the high fidelity embedding model, which might take a time to solve depending on the model complexity in terms of DOF and flexible parts and nonlinear element, etc. The very first step for simulating your model in the real time is to make your model lightweight, that is, reducing its fidelity, which can be achieved by using the model fidelity reduction feature. Once you have your lightweight model, you need to be export is as a FMU, name as a functional unit, with the desired input and output. The above FMU can be co-simulated as a slave with the third-party tools which facilitate the infrastructure needed for the real-time simulation. Concurrent simulation workbench, named as SimWB, is one such a complete real-time modeling environment. Look at how an user can export an FMU from Adams and import that into the SimWB as a database for the co-simulation. On left hand side is the Adams UI, on right hand side is the Simulation Workbench UI. Let's quickly look at how the Adams FMU export for Simulation Workbench. MSC provided an debug options where user need to specify the event name and the required input and output, and then user need to click on OK. Then FMU will be exported in the working directory. On the right hand side, on the simulation workbench, user need to be import Adams FMU. Then from that, user need to be create a RTDB. Once the RTDB created, user need to be create a test from that by specifying the fixed step and the CPU. Then once the test created, then user need to be created a test session by specifying the test session name and the fixed step. Go through Adams real-time co-simulation with Simulation Workbench through the virtual Simulation Workbench dashboard, where user will going to apply throttle, brake and steering through this virtual dashboard. Left hand side window display the animation for the full vehicle open loop handling event in the Adams car standalone solver. The FMU for the same model can be co-simulated as a slave with the simulation workbench as a master. The animation on right hand side as the user trigger the signal as an accelerator, then brake and steering result into the relevant vehicle output such as lateral acceleration and horizontal acceleration updated accordingly. Thank you.